Okay, for example 2, it says use the graph to approximate the solutions, and the key word here is also approximate. That was in example 1 as well. For the following system of equations, find f of x minus g of x for your estimates. So again, we're going to do a little x column. We're going to do f of x, g of x, and f of x minus g of x. Sorry about running out of space up here, but it'll be okay. All right, so what you're going to notice this time, and it's nice that they've already graphed it for us, but what's nice is we can kind of get an idea of what we're looking at. So I know that there's an intersection point here and here, and like I said, if it's already graphed, then you may not need to do the table. You may just look at it and tell. But if they gave you this up here, let's say they gave you these two things, but they didn't give you the graph, okay, then maybe creating the table is actually a little quicker and easier than actually trying to graph the whole thing out. All right, so what I want to do is list out some points here and see where we can think they intersect. So we're actually going to start at, say, -3. And if I plug in -3 here, 2 to the -3rd, that is 1/8. Okay? If I plug in -3 here, I get g of x, that's -3 plus 2, which is -1. So if I do f of x minus g of x, I get positive 7/8. Okay? Okay, so let's keep going. Let's go to -2. So I do 2 to the -2, that's 1/4, right? And then if I plug in -2 down here, that gives me 0. So 1/4 minus 0 is 1/4, right? -1, I get 1/2. If I plug it in here, I get positive 1. So when I do 1/2 minus 1, I get -1/2. All right, so somewhere in here, we have a 0. That means somewhere between -1 and -2, we have an intersection point. Okay? And as you can see in the graph, it's approximately -2. And the reason how you can tell the difference here is that this one is closer to 0 than the -1/2 is. All right, so let's keep going though. And then 0, plug that in, that'd be 1. And then 2, that's a -1. Plug in 1, we're going to get 2. And then 3, which is also -1. If I plug in 2, 2 squared is 4. 2 plus 2 is 4. I get that this is the 0. So there's my second one. So this one actually intersects exactly at 2. So we have 2, x equals 2 as a solution. And then x is approximately, do that for approximately, -2. Those are our 2 intersection points. Now, we'll get to the point in this class where we can find those exactly, but for now, we're just going to kind of approximate them and get an idea of what's going on here. All right? So number 3, example 3 says, use the table of values to approximate the solutions for the following system. All right? So, given the two things that we've got here, we've got 3 to the x power, 2x plus 1, 2 to the x plus 1. You can't see that that's 3 to the x power and 2 to the x power plus 1. So this one's increasing much faster. This one's increasing slower, but it starts at a higher point. So they're only going to cross one time. Basically, to get an idea of what this would look like, you're going to have something like this. You're going to have the first graph, which crosses at 2. It's going up like this. Then you're going to have the second one, which is a little bit below it. Going to cross at 1, but then it's going to speed up its increase, right? And it's going to cross. And then what we see here is that as they've already done the table before you plugged in some of these numbers, the spot where they are equal, the spot where we get the 0 value, is at 1. So this apparently would have been at 1. Okay? So you can, again, look at the table to see what an answer is without specifically having to graph it. But you have to be aware, you have to be able to check yourself enough to know, does it cross, does it ever cross, right? Are there any solutions to this? Is there only one solution or is there no solution? So make sure you go back to the notes and look at how to decide between those. All right? We're going to stop that video there.